Start. So let me know if you see this. All right. Have you seen this? Yes, no. Hello? All right, you hear me? All right, we're almost out of time, so please respond if you're hearing me. All right, good. So Kimball, I'm going to ask you to give the others a chance. All right, remember you did this activity a while ago. So this is another group. All right, this is another group. Just give the others a chance. If you know the answer, don't respond. All right.
Yes, sir.
All right. Let's begin. So the others in the group, what is the first thing that we would place in the circuit? You know, you can
Sir,
use.
you are breaking up.
I'm breaking up.
So the battery.
All right. So we first place our battery here. And what's next? You can use over here as a guide.
Sir, the wires.
All right. So let's put some wires as well. What's next?
Let's know. So the battery, the wire. So what? Wait, what's that? Oh yeah, resistor. What that be?
All right. So this is a resistor. Right. We'll use the light bulb as a resistor in this part of the exercise.
All right, then.
Yeah, just to show that there's current flow. All right, so let's put 3 light bulbs here. 3 light bulbs. All right, what's
Then
next?
use the wires to connect them.
Sir, which group am I part of?
Yeah, you're a part of this group. All right. It's nothing really formal. Right, Jordan is not hearing me. It's nothing formal. I just wanted to ensure that we all understand the concept so far. All right, so that's why I really split the class. All right, so we go ahead and connect our light bulbs. Let's do that quickly. All right, what's the next step? We connect everything else, right?
But sir, you're going to need a switch.
All right, so you will need a switch. That's good.
I have to turn it on and off.
So let's put another wire here. As well. All right. Is our circuit complete? Right. We have everything that we need.
One battery, wire, switch, and 3 light bulbs.
Are we good?
So, sir, you're not going to join that other piece of extension cord to the other piece of extension cord.
Exactly. So we're going to connect our wires, right? In other words, we're connecting our wires. All right. So let us do that quickly. Now, let us put this here. What is this called again? I remember from yesterday.
Forgetting.
So meter, right?
And meter.
Right. Okay. So this is essentially used to do what? What is this? What is this used?
Sure. I completely forget.
It's right here, right?
the current. No, sir, I was
Okay.
remembering something else, that's why.
All right, so it is used to measure electric current. All right, so why is there not current flowing? Why is current not flowing? What is happening? Something is wrong with my computer. What is happening? Why is current not flowing?
Oh, wait, nothing's. Oh, Christ. Sir, you're going to need to activate it now.
Yeah, how activate it? Because it looks like I'm wondering if it's my computer or.
So the volt, no, nothing I voltmeter.
Why is the current not flowing?
They activate it by connecting piece of the solar part over here. So.
Over where? Over the left or the right? All right, so this section here, what is this called again?
Switch there.
All right, so our switch, let's connect our switch, and we realize that current begins to flow now. No, a light comes on. What happens if we increase the voltage?
Sir, it goes. Sir, the something there.
Sir, oh.
All right, what happens to the light?
Would move faster.
Bright. Sir, the light get brighter.
Exactly. So the light gets brighter, and I heard someone says that the
Electrons.
particles, exactly, the electrons here, these are called electrons. They essentially move faster. All right, what happens to the current reading when we increase the voltage?
Increase. Sure, it goes higher.
All right, so the current also increases. Now, the last question for this exercise, how many paths of current is there? How many paths of current? How many paths of current is there? How many paths of current is for the circuit?
Oh, sir, 3. Wait. Sir, just 1.
All right, so there's just one path for current to flow.
Oh.
So are we all seeing that?
It's one switch and the 2 parts that are connected to the battery.
All right,
so just
so
1 part.
anyone not seeing that? Anyone not seeing that? All right, so there's only one path for current to flow. Now, what is the name of this circuit again?
Oh my God.
So you have two types of circuits that we spoke about yesterday. All right, you're checking back your notes.
Yes, because I forgot it.
No problem. No problem. It's new. It's new, but let's see what it is.
Sir, a series
Alright.
series circuit.
So this is called a series circuit. All right, because there's just one path for current to flow. All right, so I would go ahead now and construct another circuit that looks a little bit different than the last one. All right, give me a second. Let me just go ahead and construct it. And we place our light bulbs again. Now, how many paths is available now for current to flow?
Sir, 3.
All right, so there are now 3 paths for current to flow.
So there's a parallel circuit.
So this is called a parallel circuit. All right, so are we all seeing that?
Yes, sir.
Anyone not
sir.
seeing that?
Yes.
All right, so I know Marcy just joined. So let's do a recap, quick recap. All right, so for Morrison's sake, right, there are, we have the main components in our circuit. We have our battery here. We have our light bulbs, right? And we have a switch. Now, if we increase the voltage on the switch, on the battery that is applied to the circuit, we realize that there is an increase in the current on our ammeter here. So it increases from 0.6 to 0.221 when we increase the voltage. Now, if we do that as well, if we change the voltage, you realize that the, the intensity of the light also changes along with the speed of the flow of electrons. And we also said that this particular circuit, the current only has one path, right, for it to flow. There's only one path for it to flow, therefore it qualifies it to be a series circuit. On the other hand, this particular circuit has one path plus two paths plus three paths for current to flow. All right, so current can either go here. Let me just reduce the voltage a little bit. All right, so you can see the electrons move in here, and you have some electrons branching off, right? You can see them branching off into this path, and also they recombine. You have more electrons that branch off into the second path. All right, and you have another set of electrons that branch off into the
Sir,
third path. All right, question? I hear a question a while ago.
sir.
Yeah,
Money. Sure.
go ahead. Is that Jamie Lee?
No, sir.
All right, I'm not sure who was it. Or Miss Brown. Miss Brown, you have a question? All right. Moving on then. What if we disconnect this particular light bulb? What happens to the other light bulbs? Are they affected by that? Are the other bulbs that affected?
Yes, sir. Because he has more than.
All right, so they're not affected because I didn't hear the last part. I didn't hear the last part. They're not affected. Why are they not affected? Hello? Are you hearing me?
Yes, sir.
Yeah, why are the other two light bulbs not affected if this one is disconnected?
Sir, because I have more than one circuits.
All right, so you have more than one path for current to flow. All right, so
Yes,
are we all
yes, sir.
clear on the difference between series circuit and parallel circuits? Are we all clear? Anyone doesn't understand series and parallel circuits? Yes, no, no, sir, yes, sir.
Yes, sir, I understand.
All right, that's good. All right, so that is it for today. You may go. All right. You're free to go. Enjoy the rest of your day. All of this.